Determine how many tons of garbage were sent to each landfill in 2010.
Okay. Times 10Q, Ryan?
Yes.
Is that decimal is right there, correct? And what's the rule for the leading digit when we're putting things in scientific notation? It must be.
Greater than 1.
What are you doing, Michael?
Greater than 1. Greater or less than 1. And
No. Greater than or equal to 1.
Greater equal to 1.
2.5 times 10 to the 8th. What I'm actually doing here is like the problem-solving method, but I'm doing it really quickly without writing everything I should. All right, just writing all the things that I need. Now it says that there are about 2,000 landfills. So these are actually what? Landfills. What's the first one? What does it stand for? Tons of garbage, right? How, is it for all Americans?
Yes.
Yeah, for all Americans, right? So this is tons of garbage. And we'll put all Americans here. And it's asking us to do what? Olivia, what's it asking us to do? Read that up there. Yeah, they tell us, assuming all things being equal, how many tons per, right? Per, how many tons would there be for all of it? And if you average it over 2,000, dividing, right? Very good. Now let's look at something here. What do we call this decimal in each one of these? It's a decimal, but we have another name we call for it. We learned this right around in lesson 7. It is a word that we were focusing on. It starts with an M. Come on, class. Magnitude. Magnitude. So these, actually when we look at this, and I think it's an important concept we get, is that this 8 tells us the magnitude of this number, or how big it is, doesn't it? And this 3 tells us the magnitude of that number. Now don't we generally divide the smaller number, or the number with the smaller magnitude, from the one with the higher magnitude? We're just going to mess you up because I use the word magnitude. Don't we divide the smaller number from the larger number usually?
Yes.
Yeah. Smaller from larger, smaller magnitude, larger magnitude, larger. Okay, there we go. Now, that's the same thing here. This is all of the tons of garbage generated by all Americans, and this is the number of landfills we have, isn't it? So, what if I took our tonnage, I'm messing this up, times 10 to the 8th, and I divided it by our number of landfills, which is 2 times 10 to the 3rd. Remember, we can make this easy to do. We can separate these a little bit, so that I've got 2.5 divided by 2 times 10 to the 8th divided by 10 cubed. Now, let's deal with this one first. And if you need to, that's what you have got to. 5 times, what's this going to be? Amory? What's that going to be? 10 to the 8th divided by 10 cubed. Not sure? Let me rephrase it. When we divide powers that have the same base, what do we do with the exponent? Answer this question. Answer this question. When I'm dividing powers with the same base, what do I do with the exponents? I subtract them. Very good. Therefore, it's 8 minus 3, which is 5 times 10 to the 5th. Good job, Amory. All right. So that's actually our answer, isn't it? That's what it's asking for. Everybody write that in standard form. Standard form. Sorry? Each of our waste disposal sites in our country will hold 1.25 times 10 to the 5th tons of garbage. Right? They might have a problem with that, not be able to wrap their head about it. We say 125,000 tons of garbage, they'll get it, right? Makes more sense. They understand that number. Everybody with me? Yeah. All right, so write a sentence to represent that, if you would please.